Hello everyone. So we will solve numerical problems related to bending stress and using bending equation. So here let's see the first question. A beam is simply supported and carries a UDL of 40 kN per meter run over the whole span. The section of the beam is rectangular having depth as 500 mm. If the maximum stress in the middle of the beam is 120 Newton per mm square and moment of inertia is 7 into 10 power 8 mm power 4, find the span of the beam. So first of all, let's write the given data, all of us. So what is the given data? We have UDLW is equal to 40 kilonewton per meter, so which is equal to 40 into 10 power 3 Newton, and here in denominator there is meter, so I am converting that also into mm. So 1 meter is 1000 mm, so Newton mm. So finally this becomes 40 Newton per mm. Why I am converting into mm? Because here stress is Newton per mm square and here depth is also mm. Next, what is given to us? The section of the beam is having rectangular section, depth is d is equal to how much? 500 mm, and the maximum stress means sigma max is given as 120 Newton per mm square, and I value is given, moment of inertia, which is 7 into 10 power 8 mm power 4. He is asking us to calculate the value of span L. Okay, so initially what we have to do is, basically this is a simply supported beam which is carrying UDL over the entire span. So we know that when a simply supported beam carries UDL over the entire span, the maximum bending moment occurs. Basically the bending moment diagram will be a parabola and the maximum bending moment occurs at the center, and the intensity of this is WL square by 8. Okay, so first we should take this formula. So we will write, so I'm writing it here. So we will write maximum bending moment for beam carrying UDL. So M is equal to how much? WL square by 8. So from here M is equal to, what is the value of W? 40 into, what is the value of L? We don't know. So L square by 8. So from here what do I get? M as 5 into L square. Okay, keep this aside. Now we will take the equation for uh, maximum bending moment or moment of resistance according to our section modulus. Okay, so we know that we have, or we know that M is equal to sigma max into Z. So this is a relationship between the maximum bending moment or moment of resistance and bending stress and section modulus. So we will take this relation. So from here, what is the value of M? 5L square. So 5 into L square is equal to, what is the value of sigma max? 120. 120 into Z. So here we don't know the value of Z. So let us calculate the value of Z. So for this I am doing Z here. So first of all, how to calculate the value of Z? We know that section modulus Z is given by the formula I by Y max. This is already discussed in my earlier video. You can check it. And Z is equal to, I value is given as 7 into 10 power 8 by Y maximum. Basically for a rectangular section, if this is the neutral axis which lies exactly at the center, the maximum distance from the neutral axis to the outer fiber will be Y max. Okay, according to definition of Y max, it is the distance from the neutral axis to the outermost fiber, which is this fiber. So what was the total depth of the section? 500 mm. So obviously from here to here it will be 250. So it is 500 by 2. Here we should write, since Y maximum is equal to D by 2. So from here our Z will turn out to be 28 into 10 power 5. Now I will substitute the Z value here. So 5L square is equal to 120 into 28 into 10 power 5. So from here L square will be equal to 120 into 28 into 10 power 5 by 5, and L will be the root of this value. So L square is almost 672 into 10 power 5. So from here L will be under root of 672 into 10 power 5. So finally L value turns out to be 8197.56 approximately mm. Okay, it is in mm. Now let's say this is how many meters now? How to get in meters? Divide by 1000. So it is 8.197 meters. So which is approximately 8.2 meters. So this is how we need to solve this kind of model problem. Okay. First you calculate the bending moment according to the given loading, and then you take the equation m is equal to sigma max into z, and then substitute that m here, you will get the unknown. Okay, so this is a basic level problem. Let's do another problem. So see this problem. A timber beam of rectangular section is to support a load of 20 kilonewton uniformly distributed over a span of 3.6 meters, where beam is simply supported. If the depth of the section is to be twice the breadth and the stress in the timber is not to exceed 7 Newton per mm square, find the dimensions. So in this problem, they are asking us to calculate the breadth and depth of the rectangular section. We need to calculate the values of small b and small d. Also, he is saying that how would you modify the cross section, means how would the values of b and d change if the same beam is having a point load at the center. Means he's saying if you remove the UDL and put a point load of 20 kN at the center, how would the values of b and d change? So we have to do once for UDL case and once for simply support, I mean the point load case. Okay, first of all, let's quickly write the given data. So what is the given data for us? We have load W is equal to 20 kilonewton. See people, we should not write this as 20 kilonewton should not be written as small w, because it was not given 20 kilonewton per meter as in the previous problem. He told 20 kilonewton total load is uniformly distributed on this entire span. So it is not small w. So it is 20 kilonewton capital W, which is 20 into 10 power 3 Newton. Okay. Next, what is given to us? Span L is given. L is how much? 3.6 meters. I will convert this into mm. So 3.6 into 10 power 3 mm. Okay. And he told stress in the timber beam is not to exceed this much. Means it is already sigma max. How much? 7 Newton per mm square. So what is that we need to, and another relationship is given. The depth of the section is twice the breadth. Means small d is equal to 2 times b. Okay, depth is twice the breadth. So ultimately we should calculate the values of b and d. This b and d, the rectangular section, this is the b value and this is the d value. These two values we need to calculate. Okay, so for this, initially again, first what we shall do is we will calculate the section modulus. Okay, section modulus, how do we represent section modulus? By z. So z is equal to actually you can put I by y max, or else if you watch my previous video, already we have done section modulus for rectangular section, which is given by the formula bd square by 6. How this came means it is I by y max. So I for rectangle is bd cube by 12, by y max is d by 2. So if you cancel, you'll get bd square by 6. So z is equal to b into, what is the value of d? 2 times b. So 2b whole square by 6. So from here what will be z equal to? B into 4b square by 6. So I can cancel 2 2s are 2 3s are. So finally I will end up z is equal to 2b cube by 3. So we will keep this value aside. Now what we will do is we will calculate the maximum bending moment on the beam. So maximum bending moment M is equal to, again this is a simply supported beam as usual, which is carrying UDL. So again what will be the maximum bending moment formula? WL square by 8. Actually this should be small w L square by 8 if W is in kilonewton per meter, but this is equal to capital W into L by 8. You might ask how we got. So it is capital W, total load will be equal to W into L. If you remember, so if this is a simply supported beam, let's say example with a UDL of W and let's say the span is L, how do you get the total load on this beam? Total load of the beam will equal to what? W into L, because UDL is assumed to be like a rectangle. So it is W into L. That's what I wrote this as. This is WL square by 8, right? So I wrote this as WL into L by 8. So this WL is what? Capital W into L by 8. Okay. Now, so M is equal to, what is total load W given to us? 20 into 10 power 3. So 20 into 10 power 3 into L is how much? 3.6 into 10 power 3 by 8. So from here I have M is equal to 9 into 10 power 6 Newton mm. Okay. Now we will keep this aside. As usual, we have equation, right? What is that equation? We have M is equal to sigma max into Z. So we will take this relationship. What is M value? 9 into 10 power 6, which is equal to, what is the value of sigma max given to us? 7. 7 into, what is the value of section modulus we just now calculated? Here it is, 2b cube by 3. So 7 into 2b cube by 3. So from here, what will be 2b cube, or 2b cube is equal to, if I just write 2b cube, it is 9 into 3 into 10 power 6 by 7. And from here, b cube will be equal to 9 into 3 into 10 power 6 by 7 into 2. And from here, what will be my b is equal to this complete value, 9 into 3 into 10 power 6 by 7 into 2, 14 to the power of 1 by 3. Okay, so from here I got b value after solving as 127.47 mm. So once I got the value of b, I can calculate the value of d, because we have this relationship d is equal to 2b. So therefore d is equal to 2b, which is equal to 2 into 127.47. So my d comes out to be around 248.94 mm. So these are the dimensions of the section of the beam. So whatever we solved is still here, till this part. But now he's saying, how would you modify the cross section? Means how would the values of B and D change when a point load of 20 kilonewton is placed at the center with the same ratio of breadth to depth? Means he's saying, now as we put a UDL, no? Now he's saying the same simply supported beam is replaced by 20 kilonewton point load at the center. He is asking, how would your values of B and D change? So people, we know that the bending moment for a simply supported beam carrying point load at the center will be how? It will be the maximum bending moment will occur exactly at below the loading, and it will be like a triangle, and the intensity is what? It is, sorry, capital WL by 4. Okay, so now we will use the formula. So this I am doing for this case. For concentrated load I am doing. So for when the beam is replaced with concentrated load, so now your capital W becomes 20 kilonewton, which is 20 into 10 power 3 newton, and maximum bending moment is equal to, what is the formula? M is equal to WL by 4. So which is equal to 20 into 10 power 3 into what is L value? 3.6 into 10 power 3 by 4. So if I solve this, my maximum bending moment comes out to be around 18 into 10 power 6 Newton mm. Now we will take the relationship M is equal to sigma max into Z. So from here, what is M? 18 into 10 power 6 is equal to, what is sigma max? 7 into what is Z again? Z did not change. Okay, Z is same 2b cube by 3. You might ask, why are we putting the same value? Because in the question you see same ratio of breadth to depth, means he's saying you use the same relationship. So Z will not change. So Z is 2b cube by 3 only. Okay, so from here what can we write 2b cube as? 2b cube can be written as 18 into 3 into 10 power 6 by 7, and from here I can write b cube as 18 into 3 into 10 power 6 by 7 into 2, and b will be this complete value 18 into 3 into 10 power 6 by 14 to the power of 1 by 3. And if I solve this, my b value came out to be around 156.82 mm. So once we know the value of b, what should we do? Calculate the value of d. So therefore d is equal to 2b, right? So it is 2 into 156.82. So finally d value is approximately around 313.56 mm. So this is how you have to calculate such model of problems. Okay, so I hope you all understood the video. Thanks for watching.